So my name is Oleg, and today I would like to present you the GraphQL. But before we do this, I would like to remind you that that organizing a conference is a big task. It requires a lot of time and effort. And the best way you can thank the organizers is by providing your feedback. The best way to do it is just to go to them and just tell it them in person. But you can also use this Scala Days app to vote this talk and all talks to come. So I would like to encourage you to do this. So as soon as GraphQL was mentioned in public space, I got immediately excited about this technology. I found, I saw a lot of potential in this technology, so I thought, I think it would be very helpful to look just a little bit in the future and try to imagine how our API would look like in near future. What kind of important concept will we have in our API? And in order to do this, so let's make this small glimpse into the future and see it for ourselves. So in API, what I really would love to have is the way to discover. I think discovery aspect of API is very important. So here we see an example of an API console, and I have no idea what this API actually is. Just by knowing the basic syntax and ideas behind the syntax of the API, what I can able to do, I can get auto-completion. So this means I know that there are two fields, so I can ask for a field. Well, let's do it. Oh, something is wrong. But look here, I actually can get an error. So it's not just an error. So now I know that there's an ID argument. So this is helpful. But I also have this information at the bottom, which tells me that there is some type, and it kind of looks like a Scala in some way. If I click here, I actually see that, oh, okay, we have an argument here. Well, this is helpful. Let's add an argument. It turns out that I actually know the ID. And now we actually see a little bit more about this API. We know now a little bit more about this API. And in just several seconds into this demo, we already made the first request. Not only this, but from nothing, we discovered that there is a human, there's a name of a human. Well, we can go even further. So for example, we can discover friends. Well, friends have names. Well, now we know even more about this API, so this is great. And as you can see here, on the left-hand side, we are working not with strings. We are working with semantic data. So this means I can hover over those things, and it shows me the type. It shows me not only type, but also description of those fields. So this is helpful. It's kind of funny, because in Scala, we got used to it. We constantly use our IDEs. We constantly have this kind of feedback from IDE, from our tools, but we build this nice type system. So we use this nice type system of Scala. We model our data. But as soon as we hit this HTTP endpoint, suddenly we're starting to work with JSON blobs. All this type information is gone. And I would argue that in future, we will have a type system as a part of the API, not something external, not something written in HTML and Markdown, part of the API. Just like this one. For example, here, I can ask not only for this name, but also I can ask for a type of this data. As you can see here, the type name of this entity is a human. Well, I can go even further. I can actually ask for a type which is called human. And along the way, I have the full auto-completion. I can ask for a name and for a list of fields. So this is quite interesting. And here we see that the type system is a semantic information. It is part of the API. And the reason why I have auto-completion here also because the same fact that type system is a part of the API. So on one hand, I get here not only just the data, but also meta information about this data. And I also get two different things at the same time, which is very helpful. And not only this, but I also got exactly what I asked for. I discovered several things. I discovered this name and friends. And this is precisely what server gave me. It doesn't give me a blob of JSON with a lot of things. It only gives me something that I know and something that I need in this particular case. And documentation is also part of it, because documentation is crucial. It is important for discovery, and it is important for people who you are working with, people who you expose your API to. So I would argue that in future we will have all this information as a part of an API. But there's one more thing here. There is a dark secret here, something that the system doesn't want us to know. I know it, so I want to break this system. So let's be nasty. So as you can see here, I have those two fields. Well, I know there's another field here. Let's try it out. So now we see the hero. This is exciting. And now we know who the true hero is. Well, as you can see here, it shows that this field is duplicated. Well, there's a good reason why this field is there, because existing clients and existing customers rely on this field. They have clients, they need this field to maybe not to break their applications. But still, when I discover, I'm not shown this information. In fact, all this documentation tries to hide it from me as much as possible. For example, here I see duplicated fields as well, but I need to go extra step to get them. And I think that points out another important aspect is that duplication information is not just a string. It is part of the API, and it has semantics. And this tool makes good use of the semantics, so it tries to help me based on this semantic information. It enables tooling, and it enables a lot of interesting things which would be not possible if we just working with strings and just putting this documentation in HTML files, for example, if we have any. So this is nice. We just discovered we made a lot of requests just in the last 6 minutes without prior knowledge of this API. We already experimented with it. We already did a lot of interesting things about it. Well, now I think it is helpful to go back into the present. Oh, by the way, when I was talking about the future, I actually was talking about 30 minutes ahead of time. So in 30 minutes, you will actually learn how you can build those kind of API yourself in your applications, in your own Scala applications. It doesn't matter how big your application is or maybe how sophisticated it is. You can start step by step, and you can start doing it incrementally. But I think before we do this, it is useful to look why we can't have all those nice things. So this is a typical RESTful API. So something that probably you saw many times, and maybe you work with it on a daily basis. So here we see typical client-server interaction, where client sends a request to a server. So in this case, it's this one. So we get a product. So client tries to get a product with specific ID. Server goes to the database, fulfills this request, and gives back data to a user. Well, this data, as you can see, we get ID, version, and name. And for some reason, server makes a very, very hard decision. Server decides that, OK, this is the data that client needs. And the thing is, I spent a lot of time building RESTful API. And many times, I make very hard decisions. When I introduce a new feature, I think very, very hard how to build this perfect model, the perfect model that fits all those clients that try to access my RESTful API, because I would like to build this perfect API that fits them all. And if I don't manage to do this, if people come to me and say, oh, I have a problem, I can't access something, or this model is not right for me, then I feel better about myself, because I haven't done my job properly, isn't it? I would argue that this is not the case, actually. So I would argue that the clients themselves are inherently different. Different types of the clients require very different types of information. So some of the problems with this approach, at least on a higher level, something that is obvious, is we have this problem of overfetching. We got, as a server, we have, for some reason, somehow we decided, so this is a chunk of data that is suitable to a client. But in many cases, at least in my personal experience, most of the time clients only use 20, maybe 30% of the data. Everything else goes to waste. Of course, the problem is not new. So if you're lucky enough, the API provider will implement fields like this one. So query parameters where you can actually specify what stuff you would like to get back from the server. But we start to see here a small DSL, like with this variance.price. It's kind of unfamiliar. You don't know semantic of it yet. And this is what happens with many API I saw. There's no standard for this. So everybody, if you're lucky enough, you will find those, but you need to learn every single time how the syntax look like, what it allows and doesn't allow you to do. Another problem is underfetching. So with underfetching, even though we got all this huge amount of data, which most of it we don't need, it would be still not enough. For example, if I would like to show comments or reviews in addition to a product, well, I'm out of luck, because what server decided for me is that I need a product. Maybe if I'm lucky enough, I get some links to, especially if server uses Hypermedia API, I get links to comments or reviews or something else. But then I need to go and fetch all those additional resources. And then I end up in this n+1 problem where for every resource I also need to fetch n additional resources. And this problem also not new. For example, here, example from our own API where we allow to expand particular fields. For example, product type can have an ID in a product. And by expanding it like this, you can say, OK, when you're fetching a product, look at this ID and include a product type object inside of the response at the same time. So I only have one round trip, and I get at the same time a product information, a product type, and a tax rate and a price. But again, we start to see here, you probably never saw the syntax before if you haven't worked with our API. And if you start to work with our API, you need to learn the syntax. Because it is very helpful. Like as a client, when you're using it, it is very helpful, and it helps you to optimize your application for different use cases. And the last thing I would like to mention is the API evolution. In many cases, I saw that it comes as an afterthought. So when we are building API, we try to focus on the business logic, on things and features we would like to implement, on this perfect idea of the world we would like to make a better place. And version, well, we will think about it. Like we can always add another version, isn't it? I would argue that versioning is only one of the ways to evolve API. As we saw before, we also have deprecation. And I would argue that deprecation is much better way to evolve API over a long term. But the problem with deprecation is that so for example, our API also has a deprecation. The way we do it is we give back, from a server, we give back this JSON blob to a client, and then we say we add a header. It's called x deprecated, and it says generally that, oh, by the way, here's the data. I think you will need it, hopefully. And by the way, also this and this field, you're not supposed to use them. I will still give them to you, but because I have no idea. And this is a problem, because we don't know. Like, we want to deprecate those fields. Like, at some point, we made this decision, and we realized it was a mistake. For example, it performs very badly. Well, now we deprecate it, but then how can we possibly know whether the client actually uses this field or not? Even if clients actually see those deprecated headers, though in most cases they just simply have no idea that this header even exists, even though we put it in documentation and we try to document it and spread this information as much as possible. Many clients, many customers are just simply not aware that this thing even exists because there's no standard for it. Well, so this is a problem, in my personal opinion. We need a standard that, we need a way to evolve API, and this mechanism should be part of the API itself, because I think evolution of API is quite important. It's one of the most important parts of the API. We can't possibly get everything right in the first place, from the beginning. So this is an example of general case. So this is an example of very, very generic API where we have those small tuning bits and pieces. For example, I can include and exclude fields. But in general, we try to come up with this ideal model all of the clients. And this is what we see in most of the REST APIs. Well, it turns out that people realized that maybe it's not so perfect, and that different clients actually need different type of the data, and maybe even different API. So what people came up with is the idea of API gateway, where for different types of the clients, people build different API. So different API which is custom built. So you can maybe also you heard about this idea with the name of backend for frontend. The first time I heard about this idea of backend for frontend, I saw it in a blog post from SoundCloud. And there they described that they do build different API for mobile application, for desktop, and for other different clients. And it was necessary for them, because otherwise, as soon as you start to use REST in mobile, or especially if you use it for smartwatches and all those new kind of devices, it becomes a huge issue. It's simply unusable, because just the amount of the data, it just doesn't fit. So this is what they did. And afterwards, I learned, when I was talking to the SoundCloud team, who actually was working on this API, I actually discovered that they not only have a mobile API, they have iOS API, and they have Android API. I was surprised. It turns out that it is necessary to create API for a specific platform. They are different enough to make it necessary. So the GraphQL approach is a little bit different. With GraphQL, so GraphQL says, well, it's a good idea in general. It tries to acknowledge that we do have different types of the clients which inherently need different types of the data. But we don't want to build those custom API. We don't want to put this huge amount of maintenance effort into the API, which is kind of the same, but with slight differences. What we would like to do, we would like to provide client a power to have its own API. On the other hand, we would like to expose one generic API for all of the clients. And the way we do it is here you see the same kind of interaction between client and server as we saw before. We still use HTTP, we still use JSON as our format. The only difference here is here at the bottom. So we ask for a product with specific ID. So client asks for a product with specific ID, but it also asks for specific keys. So it says, I need a field name and description. And when you go, if you look at the response from the server, you see precisely those keys. This means that server does exactly the same thing as server did before. But now it actually gives client only things that client asked for. So GraphQL is a data query language. It was developed at Facebook, and it was used internally at Facebook since 2012. And I think it is interesting to pause for a moment and think about it. The way Facebook introduced GraphQL, it was in the context of mobile applications. This was the time when Facebook started to build those native applications for Android and iOS. And if you are using Facebook application on your Android or iOS device, well, for the last 5 years, you're actually using GraphQL. And this technology is not new, and it is proven in production on a huge scale. So it's just an interesting thought to think about. And in July 2015, Facebook decided to open source this technology and make it available for everybody. And at this point, we already have GraphQL implementations for at least 15 different languages. And I would argue that the reason why we have this a kind of widespread, it's just 2 years. In 2 years, we have more than 15. In fact, after 1 year, it was at least 10 different languages which implemented GraphQL. And the reason for this, I think, is because GraphQL is specification. This means that GraphQL is not a piece of code. It is a PDF document. It describes the syntax and execution semantics of the language. And this is what allowed me to work on Scala GraphQL implementation, and it also inspired a lot of other people in the community to start and build those. Not only server implementation, but also tools around it, because if you have a specification, you can build a tool against specification, not against Scala, not against JavaScript, not against Python, but against the specification. So in order to understand GraphQL, I think it is helpful to look at the response. So for example, I built in a smartwatch application. Because of the small screen space, I only need this data. So I only need a name, a description, and a picture of a product, because I don't have much space, so I can't show anything else. Well, this is my ideal response, and I don't accept any compromises. As a client, I want this data, and I want only this data. Well, how do you ask it from a GraphQL server? Well, it turns out that the only thing you need to do is you need to remove all the data, all the information that you don't know. And the thing we don't know are the values. And here we have a valid GraphQL query. So this query will validate and it will execute, and when server gives back a response, you'll get, the same thing. What you probably also notice here is that what I get back, the structure of the response, very closely mirrors what I define in a query. So query, and this is just by knowing this, you can actually start writing GraphQL queries yourself. You can actually use graphical that I showed at the beginning. You can start experimenting with it, because now you know how to use GraphQL. This is the most fundamental feature, and you can get around with it in most of the cases. And it's very simple. But I would like to highlight two additional features that I think are quite helpful, and they add a lot of flexibility to a client. One of them is all of those fields, you can think of them as functions. This means all those fields can take arguments. In this case, I have a picture. I would like to get a picture from a server, but I don't want any picture. I would like picture in particular size. Well, this is what server will give me back. And another one is alias. So alias allows you to use the same field twice, but use it with different arguments. For example, here I also would like to see two pictures. So I use the same field, but I use it with different arguments. And by using alias, I can use it twice, or thrice, or multiple times. So there are no surprises in the response. As soon as you formulate your GraphQL query, you know precisely what you will get back. And this is one of the main points and focus of GraphQL, is to make it as predictable as possible and allow client to describe its data requirements. So if you look at high-level picture, if you look to interaction between client and server, you can see it as a server giving client as all sets of possibilities. And those possibilities come in introspection that we saw at the beginning. So it comes in the form of a type system. Given those possibilities, client can decide. Client can say, OK, I would like this and this and this field. I would like this and this piece of information. This is what's important for me. And it sends those data requirements to a server. Server fulfills it and gives this data back. I think it's quite fascinating to think about this idea, because if you think about versioning, it is not relevant anymore. You can see different versions of the same application, just slightly different applications with slightly different data requirements. It is especially useful because how applications are distributed right now, like you need to submit it to App Store, for example, or Google Play Store. It would be verified or accepted, and then users may or may not decide to use it, to update it. In fact, in Facebook case, this was a huge requirement for them, because now, at this point, after those 5 years in production, they still support this first version of Facebook application that was deployed 5 years ago and installed, because users still use it. I mentioned SoundCloud as well, and for SoundCloud, it's a little bit different. With backend for frontend, the problem is that because you have those dedicated API for different clients, it is a huge maintenance effort, especially if you add a version into the mix. And that's because they actually need to make a very hard decision. So they define a threshold. And this threshold defines how many users allowed to have specific version of an API, or use specific version of an API until it's dropped. So it is a business decision, and it is not the best decision to make. So you don't want to drop your users. You don't want to say users, OK, either you update or you can't use our service anymore. But unfortunately, you have to do this because there's a lot of cost and a lot of effort associated with it. And I think it's also helpful to mention what GraphQL is not. So GraphQL is not a database API. And in particular, it is not an SQL. So the SQL is this very, very powerful language. You can make those aggregations, you can make joins, you can get data exactly like you want it from the disk. Well, this is helpful and this is very powerful until you realize that your query executes for 10 minutes. And then you suddenly start to think, oh, what am I doing wrong? Like, what is wrong with SQL? And then you realize that this is kind of a leaky abstraction because you need to take care of performance yourself. Then you start to learn about indexes, you start to learn about efficient data retrieval and efficient data aggregation strategies. You, as a client. And this is an issue. Well, in GraphQL, you can express a lot of ideas of aggregation, of joins, of filtering and sorting. But the way you do it is a little bit different. Everything that you expose is exposed explicitly. This means you always expose things that you know they will perform well on production. For example, with those fields and arguments, those are fundamental building tools for you. So for example, you can create a field that returns you a list of a product, and you can include a sorting and filtering. But you only expose it if you can guarantee that it will perform well. GraphQL will not do it for you. There's no those capabilities to generically generate those SQL queries or to do on the client side to do this kind of aggregation. And in fact, we're actually using, so it is also completely independent from a data store. For example, we are using it with MongoDB, with Elasticsearch, with existing legacy RESTful API. And even in memory storage, so some parts of the data actually come from in memory. GraphQL is also not a serialization format. So many people use it with JSON, and JSON is very nice and very popular now. But the way it's defined in specification is different. Specification defined in terms of generic data structures like list and map. As soon as serialization format able to handle those or represent those data types, just like JSON, you can use any format. In fact, I, for example, used it with Message Pack or Amazon Ion, which are binary data formats. And it is not a transport protocol. Many people use it with HTTP, and the first example that we saw today is actually accessing GraphQL server over HTTP. But you can actually, it is much more flexible because the surface area of GraphQL is quite small. For example, you can use it with TCP or UDP. Another example, I can use it in the context of webhooks. If you ever worked with GitHub webhooks, you probably know that you define this URL, and then what you get back from GitHub server is this huge payload about everything, literally everything there is to know about this pull request or commit. Well, I would argue that this is a problem. And if you would like to optimize it, what you can do, you can allow users to define a URL, a callback URL, the webhook. And together with this URL, you can also define a GraphQL query. And this GraphQL query will define what data client actually wants when webhook is triggered. I actually saw this in practice, and it works very, very well. So in general, GraphQL is agnostic of everything. It is just a tiny layer inside of your application, in particular inside of your Scala application. So this goes back to Sangria. So Sangria is a Scala GraphQL implementation, and I was working on it for 2 years. Just since the moment Facebook released in July 2015, the specification, I started to work on Scala implementation of GraphQL. And it turns out that GraphQL and Scala has something in common. And this is something that we know and love, and this is the type system. Well, GraphQL type system is much simpler. You can't express monad, for example. Well, I also wouldn't recommend you to expose monads via your HTTP API. Though I saw people sometimes do it. And this is the syntax. So on this left-hand side, you see the syntax of GraphQL to define a type. So this is a part of the syntax, but normally it's meant for human beings to see the structure, to see fields, and to see types of the fields. In Scala, we'll represent it like this. So we just will create a simple case class. And this case class, you see they are quite close to each other. Even syntax is very close. The only difference here is that in GraphQL, we actually express when something is optional, we need to explicitly say, like with this URL field, we need to say this field is optional. In GraphQL, it's vice versa. You need to explicitly say that something is not null. Everything else would be optional by default. And this is signified with this exclamation point. So now, the last piece that we need to do, the last remaining bit, is we need to somehow expose this data, so expose this case class to the outside world. We need to define the API. And the way we do it is like this. So first we define an object type. This is how we define a type which would be exposed with a specific name and description. And then we have a list of fields. And all of those fields also have name, the type, and this is a GraphQL type. So I mentioned that GraphQL and Scala have type systems, but they are not exactly the same. So you need to define, so you can't use a Scala type here, but you define a GraphQL type, which is limited subset of available types. On the other hand, those types actually map nicely to a Scala. This means that this whole definition is completely type safe. For example, if from this function I return something other than an int, it will be a Scala compile error. And the last bit in the field, you actually need to define this function. So this function is a key. This is where you can provide your own business logic. This is where you can access the database or do something with it. And we define this type in terms of picture. And this is the same picture, the case class. And you can access this picture inside of this resolve function via this value field. So this value is of type picture, and we can access all those different fields. So you can map it one-to-one like I did here, but you can also add additional fields, for example. And you can do a lot of interesting things later on. I will show it to you. OK, so now, except of those descriptions, for example, here I have now a nice description of this object type. And at the bottom, I have also this URL. I also provide a nice description for this field. So I find this quite useful. And I think documentation should be part of the code. It should be part of API. It shouldn't be something external. We shouldn't write JSON files, or we shouldn't write HTML files to describe semantic of our API, the type system of our API. It belongs to the API itself. And this is what we're doing here. We define in the code what is the type system of our API. And this is precisely the stuff would be exposed and would be accessible through introspection API, which we saw at the beginning. Well, but so some people prefer the syntax. You see, it's very explicit. You define all this meta information, and it is very explicit. And in fact, it makes a lot of sense for legacy API or for old API, for example, when your domain model, internal domain model, start to diverge from what you expose. But if you start with a project, if your internal model is very close to something you expose, it is a lot of boilerplate, isn't it? So we define the same thing twice, except we add additional descriptions. Well, fortunately, Sangria provides a nice marker which will derive the structure of a case class, but it will expose it as a GraphQL type. The only difference is that we actually can also provide descriptions. And I think I would like to stress this point. I think it is quite important, because what I saw in many libraries, especially when it comes to JSON transformation, they also provide nice derived macros, but you kind of end up in the situation where you need to choose, or you don't have other choice, because if you would like a convenience of a macro to derive the structure of a case class, well, you can use macro, and if it works for you, if it produces exactly what you want, you can just use it. It's just one magical line of code. It is very convenient, and it is very easy to maintain. It's just wonderful. But as soon as you have one small change, like, for example, you would like to remove a field from your type when you expose it, when you convert it to JSON, well, you're out of luck. Suddenly, you have this case class with 22 fields, and now you need to roll your own encoder and decoder for it. So you are forced to make this choice. So you actually don't have any choice here. You just need to write your own decoder. Well, I, I think we can do better in this respect, and this is what derive, object type, and other macros provide you. You can customize any aspect of derived class. In this case, I provide descriptions, which I believe it is important. If you would like this syntax, if you would like to derive the structure, but you still want to document stuff, you can do it. If you would like to add additional fields, you can also do it. If you would like to replace, rename, exclude, or include fields, make it deprecated to the outside world, you also can do it. It's not a problem, and you can still use this macro. And I think this aspect is quite important. So now the choice is yours. If you like explicit style, you can use it. But if you like this macro and you like convenience that comes with it, but you still would like to customize particular aspects of it, you can do it at any time in any kind of situation. So GraphQL also has interfaces. In fact, it has interfaces and union types, something that hopefully we'll also get in the future in Scala. In Scala, you represent this trait, and when you expose it, you just define an interface type. The structure of this meta information is it's exactly the same as an object type, except you're using interface type instead of an object type. So nothing super exciting here. And when it comes to implementing this interface, so this is how it looks in GraphQL syntax. You just implement an interface, and we also have those arguments. So we have this picture field, which we would like to expose, and we would like it to have an argument. Well, in Scala, we will normally define a method. We will define a method, and we will extend an interface. In this case, you can still use a macro, but you need to define that this particular class you need to explicitly say that it implements this interface. This is not derived. And you also need to include the method, because what macro does by default, it just takes by default it just takes all of the fields of the case class. It is the most safe option. But if you would like to include a method, you need to explicitly use this include methods setting for a macro. What it will do, it will derive not only the field, but it also will derive all of the arguments, and will execute this method with correct arguments when it comes from a GraphQL query. So it does all of this definition for you. But we also will see just in a second how you can do it explicitly. And now it comes to a query type. But before we do this, I would like to provide some way to load the data from a database. Like for the sake of this example, I just use a simple list, which well, I define in memory. But you can imagine accessing the database in this place. You can also use future here, it's not a problem. Just for the sake of simplicity, I use simple types, like just a simple list with a product and an option of a product. And now we need to define an entry point to our query. As you may, if you noticed before, when I started my query, when I showed those examples, I always started it with a product or products, with a list of products. Well, this is how you define it. You do it in the same way you define everything else. So it's just a normal object. The only difference, the two small changes here, is first I use arguments. So in this case, I define an argument, ID, and I specify what type it has. And then I define, and this is how I use it. So this is how I extract the argument from a context in this resolve function. And another difference is, you saw before that normally I defined those types in terms of something else. For example, I defined this product in terms of a product case class. Well, in this case, I don't have any entity. It's an entry point. But what I need an access to a product repository. And the way I do it is I do it via the context object. So it's the first type argument. And the first type argument, so this context object, it's available to all of the fields in the whole schema. So all of the fields in the schema have access to this type. And this type normally used for things like authorization and authentication, for user information, for database access, for external service. If you need to talk to external services, you normally do through a context object. And for this, in general, for environment information. So this is how you define the query type. And now we're actually finished, because now we have defined everything, all meta information, the whole schema for our API. Now we can do tons of things about it because we have a type system. And with type system, we can validate, we can verify, we can compare. It is very powerful. But I think the biggest, the most important thing that you would like to do with those types is to expose them, to execute. And this is an example of how you can do it. So here I used, I defined a query, but I also use here this marker, a GraphQL. And this marker will actually verify this query, the syntax at compile time. So this means if you make a mistake here, for example, I add, I don't know, something like this, it will not compile. And this is very useful for tests. For example, most of my integration tests actually look like this. It's just like 3 lines of code in most of the cases. So given this query and the schema, and when we define the schema, we say, okay, the query type is an entry point. So this is where, this is the type that defines those top-level fields. And the product repository, we can actually execute it. And after execution, so execution engine will take the query, will analyze, validate it, and will execute all those resolve functions. And as a result, you will get a future of JSON. So this can be JSON from CSS, that can be JS value. It all depends on import. So because of the simplicity of this execution, you can embed it in so many different interesting scenarios. And you also can use it in many different HTTP, with many different HTTP libraries. Like, for example, Akka HTTP. I know people use it in production with Akka HTTP and Play and JSON for us, HTTP for us, and Finagle and Finch. Those are all possible. And actually, Finch and Finagle, we will see one of the users of those. So this is GraphQL. This is how you can use. And this is now is the time. Now is the future. Now can you actually know how to build it in your API and how to expose a type system. So it's no longer hidden inside of your application. You spent all this time, all this effort to model the data, to model a type system, and now you can finally expose it and make it part of your API for other teams, for other people, for your customers, for other developers. So Sangria provides also quite a few other features. So I just would like to mention those so that you know what to search for, but I will not go deeper into those. So Marchline provides support for all those 10,000 JSON libraries that we have in Scala. Streaming support, deferred values allow you to optimize access to a database. And we have middleware and query reducers. So those allow you to statically analyze or instrument query in different ways, things like caching, metrics, things like authentication and authorization, and all those kind of stuff that can be done via middleware and query reducers. And I'm almost at the end, and I would like to highlight, so I think using this technology inside of a company, or especially introducing this technology inside of a company or inside of your team is a risk, especially for such a new technology. It's just 2 years old, at least on public. So I think it is very helpful to consider not only the technical merits of the technology, but also a community and ecosystem. Who is using it? So if you have a problem, you know that you are not alone. So probably somebody else will also have this problem, and it will be easily fixed, or community will work on it. That's why I would like to highlight some of the users who actually use Sangria in production now, GraphQL and Sangria, so that you know. So maybe it will give you a little bit more confidence or give you a motivation to look in this technology in the first place. So one of them is Twitter. So if you are using TwitterDeck, for example, or I think also a Twitter Lite, chances are that you are actually hitting a GraphQL endpoint which is served by Sangria. The New York Times, Coursera. Actually, what Coursera does is they have this very interesting architecture where they have a lot of microservices managed by different teams. And the way they do it, they have this gateways API, which is maintained by one team, and it collects the schema from all those different microservices, and it exposes it as a GraphQL API. So this is, they have several videos available online. I would recommend you to check how they use GraphQL and how it works at Coursera. Redbubble and a GraphQL. So those are just some users. I would recommend you to go and check especially GraphQL. It's quite interesting project, which is a backend as a service, which is based on GraphQL and some modern serverless technologies. And as the last thing, so I'm almost at the end, I would like to highlight something that has nothing to do with Scala, or at least not that much to do with Scala, but it has a lot to do with the ecosystem, API ecosystem and development ecosystem. For many years, when I was working on RESTful API, there was one API that I always looked up to, and it was GitHub API. GitHub made a huge effort to build this wonderful RESTful API. It was very well modeled. It was very well documented. So it was quite exciting for me to see that the next version of GitHub API, the version 4 of GitHub API, is a GraphQL API. And this technology is actually enabling. So it enabled to them, for example, to have when they release a feature, this feature is immediately available not only on github.com on a UI, but also for Travis CI, for all of the integrations, and for all of you if you integrate with GitHub via API. It was not the case with RESTful API. It was just two different bubbles. One bubble was github.com, and another bubble was RESTful API, which is meant for users who are external to GitHub. With GraphQL API, it's different, because now everybody can use the same API. And if GitHub releases a feature, it is immediately available to everybody. It also was an enabler for things like Marketplace. So I think it goes beyond those obvious choices and goes beyond of obvious technical advantages. It technology that enables companies. And I hope those references will motivate you to look at this technology if you haven't done so yet, to look and feel it for yourself, just experience it for yourself. But then, when you actually make decisions together with your team or for your company, for your project, I would like you not use those references, but just use your own experience and the merits of the technology itself. I also would like to remind you to write this talk and to write all the talks to come today and tomorrow. I would like to thank you for your attention, and those are links for the first link. The first link is to this presentation, and it contains the slides. It's already available online. And the thing is, if you remember, on the third slide, I had this demo. If you go to follow this link, you can actually play with it yourself. So this may be your first experience with GraphQL, and it's interactive, and it's available without any prior setup on the client side. But then, if you enjoyed what you are seeing, you can actually try this playground. And AKHTP, so the playground is a play example of GraphQL with Sangria, and AKHTP is AKHTP example. So this is my Twitter account. I don't think that we have time for questions, but you can. I will be outside, and I will be here at the conference for all 2 days, and actually also at Scala Summit, I think. So you can grab me anytime. I will be very, very happy to answer all of your questions. And on this note, thank you very much.